In this video, we're going to come up with pictures to explain the nature of our data. And as I promised you, the pictures I will be discussing are histograms and box plots. However, before I go to our actual data, which is the class data, I need to remind you a little bit of how to construct these two pictures. All right, we need to look at some concepts like outliers and stuff like that, so that we can then understand the pictures that we get from our own data, which is the class data. So let me go to this presentation I've prepared for you. This is just a small sample of a data, all right, because we have 50 data points in our own data, so it's too much to do it manually. In fact, I'm going to use Excel. But to understand the principle, let's start with these 5 data points. So let's say I have these 5 marks, all right, these are marks for an exam: 4, 48, 55, 58, 60. And we would like to construct a histogram, all right, a histogram or a bar chart, which are similar but not the same. But let's say we're going to construct a histogram. And how to do it? What are we trying to achieve here? Well, basically, we are trying to come up with a picture that shows frequencies. In other words, how many numbers, how many marks do I have between 0 and 10? Okay, so what I'm going to do is I'm going to take the minimum for the maximum, 60, and divide this set of data in between these partitions or these categories. That's why I started with 0 and 10. Okay, so I said, okay, my x is my number. Okay, I'm going to say, all right, how many data points, how many numbers do I have between 0 and 10? And as you can see, I have only one, this 4. All right, and notice my inequalities. In English, let me translate this to English. I want numbers that are bigger or equal to 0, but strictly less than 10. All right, 4 is less than 10, so of course I put 1 here because I just have one number. If I had a 10 in here, I wouldn't include it in here. I wouldn't include it in here because the next one is from 10, not larger than 10, but from 10 to strictly less than 20. As you can see, I have no numbers from 10 to 20, no numbers from 20 to 30, no numbers from 30 to 40. Then I have equal or larger than 40, less than 50. Okay, and so I have this one number here, 48. Okay, this is called the frequency table, right? From 40 to 50, I have 1. From 50 to 60, but less than 60, I have 2. I cannot include 60 because 60 is equal to 60. So I cannot include it in the less than 60 numbers, right? And I have 2, which are 53 and 55 and 58. So I put 2 in here. Then from 60 to 70, less than 70, I have 1 because I just have 60. Okay, so notice what we're doing. We have categories, all right, boxes where we're putting in numbers, and we're counting how many numbers go into these boxes. All right, and now what do? We plot a histogram. All right, let me show you how to plot this histogram. So let's say I have, there it is, it appeared suddenly. So let's say I have, on the x-axis, I'm going to put my endpoints. Okay, so I'm going to start from 0, 10, 20, 30, 40, 50, 60. So on the x-axis, I put the endpoints of my categories. All right, there they are, from 0 up to 70, okay? And yes, include the last one because you want to complete the box. So always include the last one, right? On the y-axis, all right, so on the x-axis, I'm putting the grades because, as I said, these are grades. And on the y-axis, I'm going to put in the frequencies. Try to always follow this pattern. Y-axis, frequencies, x-axis, your particular numbers. In my case, they are grades. So 1 and 2 because I just have 1 and 2. With regards to frequencies, I just have 1 and 2. So on the y-axis, I put 1 and 2. Now, these boxes show me the frequencies. For example, from 0 and 10, I had one number, which is 4. So the frequency is 1. Between 10 and 30, between 10 and 40 actually, between 10 and 40, so between 10 and 20, 20 and 30, 30 and 40, I had nothing, 0, 0, 0, right? So here, I simply draw nothing, okay? Then from 40 and 50, I had 1, which was 48. From 50 and 60, I had 2 numbers, all right, which were 55 and 58. And from 60 to 70, I had 1 number. What is this picture telling me? My numbers are pretty bunched up between 40 and 70, all right? Most of my numbers, well, 2 of them, are between 50 and 60, and then I have this shape. Remember this shape, all right? That lonely 4 seems to be something of a beast of his own, all right? It is pretty clear that 4 does not fit with the rest of the group, right? If these were marks, this person here is not keeping up to date with the rest of the class, okay? And the histogram is already showing me that. Another way to picture this, but perhaps even more enlightening, is a box plot. A box plot which looks something like that. I'm going to show you how to construct it, and then I'm going to show you how to interpret it, all right? So, again, let's have these 5 numbers, same 5 numbers as before, 4, 48, 55, 58, 16, all right? Now, we're going to need 4 pieces of information, and these are called quartiles. This is called quartile 1, quartile 2, and quartile 3. Now, what are these numbers? Well, these numbers tell me how my data is divided into percentages. So let me try to explain it a little bit better. Let's say your principal tells you, I want to know what is the cutoff point for the first 25% of the class, or the bottom 25% of the class. And my answer here, which I'm going to explain in a second, how to construct it, my answer of 48 here can be interpreted as follows. 25% of my students have obtained a grade of 48 or less. Okay, 25% of my students have obtained a grade of 48 or less. How do I construct it? Well, take the median. The median is exactly the middle number. All right, of course, they have to be in order. They have to be in order. So take the median, which is 55, all right, and take the first batch of data, right? In this case, I have 3, which ends at the median. So in my case, I took 48 and 55. Then take the middle number of this first batch of data. All right, it's like I'm taking the lower, it's exactly that. I'm taking the lower 50% of my data and finding the middle points. So it's the median of the first 25%, the median of the first 50% of your data. And what is the median of 50%? It's 25%. That's why I'm saying the first 25% of my grades, okay? So I will repeat. I took the lower half of my data for 48, 55, and I found the median. And that median is called Q1 or quartile 1. The interpretation is that 25% of my numbers sit below 48. Q2 is just the median, 55. So Q2, there is nothing to worry about, it's always the median. And as by now you can imagine, Q3 is the median of the upper half of my numbers. So I take the upper half, 55, 58, and 60, and Q3 is simply the median of this batch. What is the interpretation? 75% of my students have obtained 58% in the exam or less. All right? I repeat, 75% of my students have obtained 58 or less. Just to give you an idea of how bunched up or spread out your numbers are, we compute what is known as IQR, the interquartile range, IQR, which is basically Q3, 58, minus Q1, 48. So this is always Q3 minus Q1, all right? And this tries to tell me how bunched up my numbers are. The higher this number is, the more spread out, all right? We'll talk about spread later on, but now this gives me an intuitive idea. The larger this number is, the less bunched out my numbers are. The lower it is, the more grouped together they are. All right? Now, we have mentioned that 4 appears a little bit like an alien, an odd one out. All right? These are bunched up close to each other, and this 4 is a little bit something of an alien. So we have created a system whereby we actually can come up with a scientific way to say, yes, that number is an outlier, or no, that number is not too far out to be an outlier. Okay? So we compute what are known as the lower, all right, the lower bounds. Well, actually here I'm using a different word. So let me just here put lower outlier and upper outlier. Lower out, because you can have an outlier at the bottom, all right, a number that's too small to be considered part of the group, or a number that's too high to be considered part of the group. You have a person who's getting 98%, 99% in the exam, and everyone else is getting 40, 50%. All right? So what do? We compute this formula. Later on, I will explain the intuition behind it. But basically, if I take Q1 minus 1.5 times IQR, you can see the numbers, I get 33. What does it mean to get 33? 33 means that it's my cutoff points. Anything below 33 will be considered too far out at the bottom to be part of the group. So 4 is an outlier. 4 is an outlier because 4 is below 33, so it is a lower outlier. Okay? Now let's look at the upper outlier. This time it's Q3, 58, plus 1.5 IQR. So 58 plus 1.5 times 10. And you got 73. So anything above 73 is an upper outlier. Upper outlier. Okay? Which means that we have no upper outliers because our highest mark was 60. So we don't have any upper outliers. Okay? Now, a box plot, and now you can understand what a box plot is. A box plot is a way to combine all this information on a diagram, right? We call it box plot because in the end, you get a box, right? Yes, I know, I have no imaginations. What do? Well, before starting, go on your y-axis and mark down your maximum number. Let me do them in red, which our case was 60. Let me do it in red. 60. Your Q3, which was 58. Your, sorry, here I have an extra. Max, I repeat, was 60. Q3 was 58. Q2 was 55. Okay. And Q1 was 48. Right? And then construct a box, a closed box with Q3. So the top part of the box is always Q3. The lower part of the box is always Q1 at 48. And this horizontal line always marks the middle. And close these three in a box. As you can see, this is a small compact box. And that's the great thing about this diagram. We got a small compressed box, which means that my numbers are pretty much bunched in the middle. All right? Even the maximum, the t here, represents the maximum, which is at 60. And it's also very compressed with the box. Imagine if I had obtained something like this, all right? Imagine if I had obtained something like this. That would mean that you have a bunch of numbers bunched in the middle, but then you have some numbers up here at the top. All right, so there's a high number of numbers in the middle, but you still have some higher numbers. But in this case, we don't have that in our numbers. All right, we just have a bunch of numbers in the middle bunched up and the maximum that's very close to the rest of the group. Then down here, we have that lonely 4. Notice, I don't plot LORT because I don't consider this 4 as my minimum. That 4 is not a minimum. That 4 is an outlier. It's not part of the group. All right, so I represent it with an X. Let's say, just for the sake of argument, I had a number, for example, 40 here. 40 is still above 33, so it's not an outlier, but it's a minimum number. What would I do? I would add a T here next to 40 to represent the minimum. So the lower T represents the minimum, the higher T represents the maximum, the box is Q1, Q2, Q3, and this star is the outlier. All right, in this case, we don't have any minimum values because the minimum value is 48, right? So we don't have to represent as LORT. So we just stop here. All right, so what does the box tell me? My data is bunched up. The highest value is very close to the rest of the group, okay? And my 4 is an outlier. This 4 does not belong with the rest of the group. In the next video, I'm going to apply this knowledge of box plots and histograms, and we're going to apply it to our data sets. All right? We're going to see what picture comes out and what we make out of it. Okay?